Hello everyone, myself Mahesh Prasad. We are from AIML department. The diagram contains ESP8266 sound sensor, LEDs and buzzer. Here the analog contains direct ESP8266 to analog, which converts the digital signals. Here this is the ground, and here VCC is the positive connected to ESP8266 3 volt. Here we taken direct path to ground for LEDs and buzzer. Here all three contained in same straight path. If it is normal, then it shows green signals. If the sound is more, the next convert into it. Next it will be converted into red. The buzzer will detect and the noise level will. Here next it will convert it into ground, connected to ground. Next will be continued by Karthik.
Hi, myself Karthik. I am explaining the hardware. To let's see the hardware of my project. To come here, and this is ESP8266. This is used for collecting the data and connect the sensor. The ESP32. See this. Ground is connected to minus. Ground is connected to ERP in this breadboard, minusing, and 3 volt is connected to positive. This makes this is also, this row is old row is negative and this old row is positive. And next this these digital pins are connected to the one for buzzer, one for light, and one for green light, and one for red light. And next pin is connected for this sound sensor, because readings the analog value is go to the ESP32 input value is analog value. These are all the output connections. And let's break down the connection of this. Our project is the sound sensor. The sound sensor detects the noise instances. It collects the sound waves, convert to electrical signals, and send the electrical signal to the microcontroller. In coding we set on safe limit. Microcontroller read the analog values. If analog value is greater than safe limit, the red LED is on and the buzzer will sound. If the collected value is less than safe limit, the green LED is on. In this time I am speaking because of the red LED is on. Let's do the silent and let's on the green LED. To see the here before 1 minute the red LED is on. In this time the green LED is on. We are method. We are talking the red LED. They detect the waves. Let's see this. Hello. Let's see the sound waves are reading to the noise sensor, and the red LED is on. And before on time and after on time, let's see this. Hello. It detects sound waves because of the red LED is on. And the microcontroller, we power supply, we connecting the power supply for the microcontroller to activate, and this hardware is run this. And next will be continued by KV9.
Hi, myself Vinay, and I am going to explain what I did after the coding in this. First of all, we defined the blink, and we enabled the blink, and we kept as a SSID as a project. Next we kept password to connect the Wi-Fi. Being it is a ESP2 microcontroller, ESP8266 microcontroller, it enables the Wi-Fi. We can connect by the microcontroller. Next we defined the RLED at D5. It is a digital pin. That is at D5 we inputted In D5 we inputted a RLED, and in D6 we inputted a GLED, and in buzzer we inputted a. First I am defining the RLED at D5 at this node, at this D5, next D6 at GLED, and buzzer at D7, and we included at the, which is the inputted, the audio is inputted of for this noise monitoring, remaining all the events are as coming as an output. Next we inputted a CF value as a 42 from which is the electronic signal is this is the sound sensor, which is the sound sensor which converts our sound into the frequency of sound waves into electrical signals, which it converts, and we kept a safe limit 48. Next we wrote the cases for the 48 blink write, virtual write V1. At V1 pin we inputted that is a loud noise is detected. It is in a string format. Next if VLED is if the value is greater than 48, it's the RLED is on, so that we inputted as high. Next buzzer is also on, we inputted high, but GLED is low, it is off. High means on, low means off. We kept a delay for the 1000 milliseconds, it means 1 second. And now I will explain how the output works. First of all, we connected the power supply. This is the power supply. We used the USB cable. Next, as before I said that the RLED is connected to D5, and GLED is connected to the D6, and buzzer is connected to the D7. And we inputted the for sound sensor. We inputted the analog pin, that is A0, and this is the structural view. This is a plus and minus. This a plus button. It is the symbol of a plus. It's complete. The row is completely positive. Next minus, it complete the row is ground level. This is the simple, and here now it works on a parallel way, where here it works on a column wise. See now if I talk this much of, we increase our limited so that it doesn't change us. When I kept a pressure on this, it is above a safe limit. It shows the now R is increased. Hello. See, it's very easily RLED is on. When I kept so much of pressure on it, because we increase the limited. Next, when RLED and this is the noise monitoring system we built. Next was controlled by Malikarjun. Next, output to displayed in displaying in laptops and mobiles. Coming next. By using the blink connection, we inputted that is what is the audio, that is 31, now 31, 38 varies, and status, that is string in format, and it is in integer format. Now we can sound it as 48. It increasing and decreasing. It's how it works in mobile, and it shows the, see how it decreases and increases happens. Continuously monitoring, it is a very simple. Next, it shows the graph in it, like we inputted the serial monitor. How it increases, how it decreases, it shows the graph, and which increases the analysis. Hence here this shows the graph, and next was continued by Malikarjun.
Myself Malikarjun. Today I am explaining about IoT noise monitoring system, which is applied for the industries. The IoT noise monitoring system is to design and measure the monitor noise level in the industrial environment in a real time. It uses the sound sensor to detect the sound and a microcontroller ESP8266 or ESP32 to process the data and collect the noise data to send the cloud through a Wi-Fi where it can wave on a web or a mobile dashboard. The system helps to industry protect works for a harmful noise or monitor the machine conditions and comply with the noise pollution regulations. When a noise exceeds a safe limit, the system triggers the alters using a buzzer and LED or a mobile notification, continues the data storage and helps to analyze the reporting. The overall IoT noise monitoring system tool is a low cost and a smart and automated solution that improves the industrial safety and the noise pollution to support efficient monitoring the decision making. Thank you.